Hi guys, welcome back to Sigma Maths. This is the second A-level sequences and series video in which we'll be going through a range of questions together on the arithmetic sequences and series content we learnt in the previous video. Now remember guys, the whole point of these videos is that you have a go at each question first by pausing the video, and then we go through the question together. Let's have a look at question 1. So we've got the third, fourth and fifth terms of an arithmetic series given in terms of x. The question requires us to find the value of x and the sum of the first 17 terms. Now what we know about arithmetic series is that they go up by the same amount or down by the same amount every time. So the difference between the fourth and the third term will be the same as the difference between the fifth and the fourth term. This allows us to write down an equation in x. So we will have 2x plus 1 minus the third term, x plus 2. Now because that is an expression, we must be careful and put it into brackets. This has to be equal to the difference between the fifth and the fourth. So 4x minus 5, take away brackets again, 2x plus 1. Let's simplify this down. So 2x take away x is x, 1 take away 2 is minus 1. On the other side we've got 4x take away 2x, 2x, and negative 5 take away 1, negative 6. We're trying to find x, so I'm going to take away x from both sides of the equation to give me x on this side, and I'm going to add 6 on both sides to get a 5 over here. So we have x equals 5. Now we are finding the sum of the first 17 terms. So the sum of the first 17 terms, this is going to require the SN formula, so let's just write it down up here to make sure that we remember it correctly. Now it is given in the formula sheet, but it's always good to know your formulas off by heart. Now we don't actually have our A and D yet, so we're going to have to go back with the information we've just worked out and use these expressions in the question to work backwards to A and D. So U3 was x plus 2, U3 is A plus 2D because it's A plus n minus 1D. That must equal x plus 2, x is 5, so that's 7. And the next term will be A plus 3D, and this equals 2x plus 1. When x is 5, that would be 11. So now we can solve these simultaneous equations very quickly because they are very nice and easy. If we subtract the first equation from the second, we very quickly find out that D is 4. And using that information along with the first equation, A is 7 minus 2 times 4, so A is negative 1. Now we can write down the sum of the first 17 terms, that's S17. So it's 17 over 2 times 2 times negative 1 plus n minus 1 is 16 times D, which is 4. And if we work all of that out, we get 527. Question 1 done. Okay, question 2. So we got the sum of the first 5 terms, sum of the first 5 terms is 70, and the sum of the first 9 terms is 36. So we've got S5 is 70 and S9 is 36. So like the last question, we can now write down some equations linking our unknowns together. So that's A and D that we're trying to find here. So SN formula, 5 over 2, so that's n over 2, times by 2a plus n minus 1, which is 4d, must be equal to 70. Let's tidy this equation up before we move on to the next one. So the 2 cancels with the 2 and the 4 here. So we get 5 lots of a plus 2d equals 70. And then if we divide both sides by 70, we get divide both sides by 5, we get a plus 2d equals 14. The second equation, that would be 9 over 2 times 2a plus 8d equals 36. Again, the 2 cancels, 1 and 4. So we get 9 lots of a plus 4d is 36. Divide both sides by 9 and we will get 4. Simultaneous equations, we'll subtract the First one from the second one, so a's cancel. 4d minus 2d is 2d. 4 minus 14 is minus 10. And we have got d is negative 5. Use the first equation. A is 14 minus 2 lots of minus 5. So that gives us 14 plus 10, so A is 24. There we go. Right, that's part A. Part B. Find the number of positive terms in the series. So we need to effectively find the first term that is negative. So when is un less than 0? That's what we're asking. Now un, we can write down an expression for this now because we've got A and D. So it's 24 minus 5 lots of n minus 1. This is the A plus n minus 1d formula. So that would be 29 minus 5n. And we want when this, the first time this is negative. So we just solve this inequality. And we get that n must be larger than 5.8. So the first negative term must be when n is 6. Therefore, there are 5 positive terms in the series. 5 positive terms. Okay, part C, hence find the maximum value of Sm. So if you think about going through this series and adding up the terms, initially we're adding positive numbers together, and then at a certain point we will start adding on negative numbers, and therefore the value of Sn will start decreasing. Now in the last part of the question we worked out that there are 5 positive terms, which means as soon as you get onto S6 and S7 and S8, you're now adding on negative numbers and Sn will go down. Therefore S5 must be the maximum value that the sum to n terms can reach. We don't even need to do any calculating here because we have in fact been given S5 in the question, so 70 is the largest. We could always check and work out S6, and we should find that S6 is less than 70 and will continue to decrease from then on because each term is negative. Okay, good. Question 3. Okay, so we've got some fractions in this one. We've got the 4th and the 9th term, so let's write down what we know then. So 19 over 24 is equal to the 4th term, which is a plus 3d, and 17 over 12 is equal to the 9th term, which is a plus 8d. Once again we have simultaneous equations, so we are going to subtract the first term from the second term. That gets us 5d here, and now we need to subtract our fractions. So taking every opportunity to not use our calculators. Oh, that's the wrong way around. We are going to do 17 over 12 minus 19 over 24. Common denominators, so change the 12 to a 24. 17 becomes a 34. 34 minus 19 is 15. So we get 15 over 24. Keeping our minds sharp by doing things in our head or using written methods. So from this we can cancel the 5s and we get d is 3 over 24, which is 1 over 8. And we can work out a by taking the first equation and doing 19 over 24 minus 3 times 1 over 8, so that's 3 over 8. Again, 24. Common denominator, we had to times that by 3, so this is 9. So 19 minus 9 is 10 over 24. Always simplify your fractions. 5 over 12. So we've got our first term and our common difference, 1 over 8. B, show that the sum of the first n terms, Sn, is given by this formula where k is an exact fraction to be found. Well, now that we've got a and d, we can just jump into using Sn. So it's going to be n over 2 times by 2a. So that would be, if we did 5 over 12 times 2, that would be 5 over 6 plus n minus 1 times d. d is 1 over 8, so 1 over 8 times n minus 1. Okay, let's continue to tidy this up. So this is going to be 5 over 6 plus an eighth n minus an eighth. So we need to do 5 over 6 minus 1 over 8. So let's make these both 24. So here we had to times by 4, so that's 20. Here we had to times by 3, so that's 3. So that gives us 17 over 24. So in here we are going to have an eighth n plus 17 over 24. Okay. So let's see, we can take out 24 from 1 over 24, sorry, from these terms. We're going to do that because we know we're looking to have integers inside the bracket. And the largest denominator here is 24, so that would be the most sensible thing to take out. So if we take 1 over 24 out, that's going to give us n over 48. Taking 1 over 24 out of 1 over 8 gives us 3n, and then the 17, as expected in the question, which just leaves us to pick out the value of k, which is the fraction multiplied by n here, which is 1 over 48. We are done. Right, question 4. Okay, so we've got an arithmetic series given by these expressions in k, and then we actually finish on a number, so it's a set number of terms. Find the number of terms in the series in terms of k. Well, we can start by writing down what we know, which is that a is k plus 2, and the common difference, if we have a look here, we're adding on a k, and then we're going 2, 5, 8, so we're adding on 3 as well. Now we need to find out what term this is, un. So firstly, let's write down un generally. So it's a plus n minus 1 times d. And now we have that that must be equal to 489. So k plus 2 plus n minus 1 times k plus 3 is equal to 489. So we're trying to get n as the subject. So I'm going to start by taking away the k plus 2. So that would be 487 minus k, because I took away the 2 as well and the k. Then I'm going to divide by k plus 3, so 487 minus k over k plus 3. And then we need to add 1 to both sides. Now I'm going to save myself some working here, and if I was to plus 1 here, then I would have to actually plus k plus 3 over k plus 3 in order to put these fractions together into 1. So k plus 3 gets added onto the top over k plus 3, and then that tidied up would be 490, the k's cancel, over k plus 3. So that's how many terms we have in this series in terms of k. That's A. Part B. Show that the sum of the series is given by this interesting looking expression. So now we are using our SN formula. So n in this case is 490 over k plus 3. So we're going to halve that. So we will have 245 over k plus 3. And then we're doing 2 times a, so that's 2k plus 4, 2 times a, which is this thing here. And then plus n minus 1, so 490 over k plus 3 minus 1 times d, which is k plus 3. So let's carefully tidy this up. We're still going to have the 245 over k plus 3 there. Inside, we're going to have 2k plus 4. Now if we expand these brackets rather nicely, the k plus 3's will cancel out, so we're going to get a 490. And then we're just going to get a minus 1 lots of k plus 3s, so that's minus k minus 3. And that tidies up to 2k minus k, which is k, and 490 plus 4 minus 3, which is 491. 245 over k plus 3. Okay, we're almost there. Let's expand the bracket and write it as a single fraction as given in the question. 245k plus, hopefully, 245 times 491 equals the number in the question. Yes, it does. So 10, sorry, let's get rid of that. That's 120,295 all over k plus 3. There we go. Okay, part C. Given that Sn equals 3,661, find the value of k. So we are now going to solve this expression from part B equal to 3,661. So let's see, 245k plus 120,295 equals 3,661k plus 10983. So if we subtract the 245k, we will get 3,416k on that side, and then if we subtract the 10,983 from the other side, we will get 109312. Dividing both sides by 3,416, we get our answer of 32. Okay, so question 5. John has some sticks of equal length. He arranges them in shapes as shown below and made the following 3 rows of patterns. Find the expression in terms of n for the number of sticks required for the nth row. So basically they're asking us for un, where this is u1, this is u2, and this is u3. So let's quickly count up the sticks. So here we've got 5, then we're adding up 4 to get 9, we're adding another 4 to get 13. So we have got first term of 5 and common difference of 4. So un therefore would be 5 plus 4 times n minus 1, which would be 4n plus 1. Okay, part B, if you continue to the pattern to create 10 rows, what would be the total number of sticks? Be careful here not to jump into U10. It's not the number of sticks used in the 10th row, but all of the sticks from rows 1 to 10 inclusive. So what we actually want there is S10. So let's pop that down here, S10. So that's going to be 10 divided by 2, which is 5, times 2a, which is 10, plus n minus 1, which is 9, times the common difference, which is 4. So that's 36, 10, so that's 5 times 46, which is 230. Okay, part C, he starts with 2,144 sticks. He continues the pattern, completes k rows, but does not have enough to complete k plus 1. Show that k satisfies that inequality and find the value of k. Okay, so if we write down what sk is, so this is the number of sticks required to complete all the way up to k rows, that would be k over 2 times 2a, which is 10, plus 4 lots of k minus 1. Let's tidy that up. K over 2 times, that's going to be 4k minus 4, so that will be 4k plus 6. We can halve through it, so we've got k times, that will be k times 2k plus 3. Okay, so if we can complete the kth row, then it must mean that the number of sticks required to get up to that row must be less than or equal to the number of sticks that we have. So if we sort this out, we're going to have 2k squared plus 3k and then minus 2,144. And really here we're just checking that this does indeed factorise to what's given in the question. So they're suggesting 2k plus 67 and k minus 32. So we just need to check then that 67 minus 32 times 2 is 3, which it is, and that 67 times negative 32 is minus 2144, which it is. So we are done. It says find the value of k. So cannot be from this bracket because that would give us a negative value of k. And we're counting rows here. Counting numbers are always positive. So therefore k must be 32, because it would be that k has to be less than or equal to 32. And we want basically the highest row that we can make with our 2,144 sticks. There we go. We are done with question 5. So finally, question 6. This is the last question of the video. Okay, so on Lisa's 12th birthday, she started to receive an annual allowance. The first annual allowance was £400. So this is when n is 1, 12th birthday, and she receives £400. Each of the following birthday, her allowance increased by £150. So for example, when n is 2, it's her 13th birthday, and she would therefore receive £550. So A is 400, D is 150, and just a note, when n is 1, I'm going to capital B for birthday is 12. Need to make sure that we understand the link between those two numbers. Okay, bar A, find the amount that she receives on her 18th birthday. So we are looking for her birthday to be her 18th. That is 6 years ahead of her 12th birthday. So if we add 6 on to n, we're actually looking for n is 7. So this is the amount she gets on her 18th birthday, not how much she's got up to and including her 18th, which actually is part B. So we're looking for UN here, not SN. So U7 is what we want. So 400 plus 6 times 150 will be how much she gets. So that would be £1,300 as her annual allowance on her 18th birthday. Part B then wants the total she would have received up to that point. So that's S7, not S18. Remember, with this link between N and the year of her, what birthday her age is. So this is going to be 7 over 2. Should be getting to know this formula quite well now. 2a, so 2 times 400 plus n minus 1, which is 6 times the common difference, which is 150. Okay, so let's see what we get from that. Pop it into our calculators. 800 plus, and we get £5,950 she will have received in total up to and including her 18th birthday. Okay, part C. When the total of the allowances that Lisa has received reaches 19,250, the allowance stops. How old was she when she received her last allowance? Okay, well, let's find out how many years it takes for her to get to a total of 19,250. So SN is n over 2, and then 800, which is 2n, plus 150 times n minus 1. And we want to know when this reaches 19,250. So let's times up by 2 on the other side and expand this bracket. So we're going to have 800n plus 150n squared, so I'm multiplying the n out, minus 150n, and that's going to equal 38500. Okay, so let's turn this into a quadratic. 150n squared plus 650n minus 38,500. Well, we can do some simplifying here. So if we drop to 0, for example, we would get to there. Divide by 5. We would have 3n squared plus 13n minus 770, and then we're hoping this factorizes. So to make this quick, we're just going to pop this into the factorising function on our calculators, and we find it does factorise. So we're going to have a 3n at the front of one of the brackets, n at the front of the other. We get a minus 14 and 3n plus 55. There we go. So this one doesn't give us a solution because n would be negative. This one does. N is 14. Doesn't mean that it's her 14th birthday. Obviously that wouldn't make sense because it's only 2 years after her first allowance. So we need to work out what her birthday would be then. So n is 1 to n is 14. This is plus 13 years later. So that's her 12th birthday. If we add on 13 to her 12th birthday, then it would be her 25th birthday when she receives her final annual allowance. There we go, 25 years old. Okay, so that brings us to the end of our practice video on arithmetic sequences and series. The next video in the series we are going to be learning all about geometric, so please be sure to watch out for that one. If you found the video helpful, then please don't forget to like and subscribe to the channel if you'd like to see more. I really do appreciate your support, and I will see you in the next one. Bye.